Question 12 of this exercise says, two poles of heights 6 meters and 11 meters stand on a plain ground. So here's a sketch I've drawn corresponding to this statement. We have two poles standing on a plain ground. The shorter pole is 6 meters tall and the longer pole is 11 meters tall. Okay. Now the statement says if the distance between the feet of the poles is 12 meters, so the distance between the feet of the poles, so this distance is 12 meters, find the distance between their tops. So the top of the first pole, let's take this point, and the top of the second pole. If we join them, what is the length of this segment, or what is the distance between the tops of the poles? This is what we have to find in this problem. Okay, so let's label the various points in the figure. So let's say that the top of the first pole is point A and the foot of the first pole is point B, and we see that the first pole is perpendicular to the ground. The second pole is also perpendicular to the ground. Let's call the top of the second pole point C and the foot of the second pole, let's call it point D. So we have to find the length of AC. So here's what we are going to do. From the point A, from this point, let's drop a perpendicular to CD, to the second pole, like this. Okay, so, and you'll soon understand why we are doing this. So basically, let's drop a perpendicular from point A to the second pole CD, and the foot of this perpendicular, let's call this point E. So what we have done is draw AE perpendicular to CD. Now this means that DE, which is this length DE, this will be the same as AB. So DE will be the same as AB, which is 6 meters, and therefore CE, this length will be how much? So CE will be the total length of the second pole, which is 11 meters, minus DE, which is 6 meters. So CE we will get as 5 meters. Okay, and also AE, this length, AE, what will this length be equal to? This length will simply be equal to BD. So AE will be equal to BD. So AE will be equal to 12 meters. And these things follow because we have drawn AE perpendicular to CD. So ABDE is a rectangle. Alright, now what we are going to do is we are going to take the triangle ACE. Let me highlight it for you. ACE. And now we are simply going to apply the Pythagoras theorem to this triangle, because in this triangle we already have two of the lengths and we need to find the length of the hypotenuse AC. Okay, so using the Pythagoras theorem in triangle AEC, and we have to find AC. So AC is equal to the square root of the sum of squares of other two sides. So AE square plus CE square. Now let's plug in the values. So AE is 12 meters. So we get root of the square of 12 meters plus CE is 5 meters. So 5 meters square. So this gives us root of 144 meters square plus 25 meters square, and 144 plus 25 is 169. So we get root of 169 meters square, and 169 is simply the square of 13. So we take the square root. This gives us 13 meters. So the length of AC is 13 meters, which means that the distance between the tops is 13 meters. Okay, so the answer for this question is 13 meters, and this completes question number 12. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.